So welcome guys. Today we are going to start the reinforcement learning series, and I expect you have some basic understanding of machine learning and deep learning. So let's start. Machine learning. So machine learning is defined as the study of computer programs that leverage algorithms and statistical models to learn through inference and patterns without being explicitly programmed. That simply means giving the model that intelligence to deal with any arbitrary situation rather than hard coding it about every uncertainty. So there are three types of machine learning. One is supervised learning, that is task driven, and the other is unsupervised learning, that is data driven, and the third is reinforcement learning, where we have to learn from errors. So let's study in detail about all of them. So we have supervised learning. So in supervised learning we have labeled data and we train our model on that data to give the model some understanding. So in future, if an arbitrary instance is shown to model, it will be able to predict that specific instance correctly. As we have our example, that is the spam detection problem, as you can see in the picture, where we train an AI model on examples of spam and normal mails, where input is the mail text and the output is its class label, that is a spam or normal. And so model get understanding after the completion of training of spam and normal mails, and make use of that knowledge to predict on unseen samples. Then we have unsupervised learning. Actually in that it is used for analyzing and grouping data which does not include pre-labeled classes or class attributes. So unsupervised learning can be used to do clustering when we don't know exactly the information about clusters. As you can see, and take an example, let's say you have a YouTube channel. You may have a lot of data about subscribers of your channel. If you want to detect groups of similar subscribers, then you may need to run a clustering algorithm, like this group of subscribers are below 21 in the age and this group of subscribers are above 30 in age. And one more, as like we can see in the picture, there is a fruit salad and no class label on any fruit. Then AI algorithm was successfully able to cluster together the similar looking fruits or whatever pattern used by AI algorithms for identifying that any arbitrary fruit belong to a specific category or class. As at last we got a cluster of apples and another cluster of watermelon. Now we're going to study about reinforcement learning. So basically it is one of the three basic machine learning paradigms alongside supervised learning and unsupervised learning. The basic idea is there is a learning system called an agent that can observe the environment, select and perform actions and get rewards in return, or penalty in the form of negative rewards. It learned by itself what is the best strategy, and we call it a policy, to get the most reward over time, and the policy defines what action the agent should choose when it is in a given situation. So as in this case, as we can see in the picture, the environment is maze with cookie at some points and fire at others. The robot ant, that is our agent, can take actions such as turn left, right and move forward. At each moment, it can observe the full state of the maze to make a decision about the actions to take. The robot ant tries to find as much cookie as possible while avoiding getting into fire whenever possible. These cookie and fire burns stand as the reward that is given to the agent, robot ant, and by the environmental as additional feedback about the agent's action. So basically the environment gives the additional feedback about the agent's action whenever an action is performed. The final goal of agent is to get as much total reward as possible. So in our specific example, this robot ant could suffer a slight fire burn to get to a place with plenty of cookie, and this would be a better result for the robot ant than just standing still and gaining nothing. However, we are not completely blind, as in unsupervised learning setup. We have a reward system here. The reward can be positive from gathering the cookie and negative from fire, or neutral when nothing special happens. By observing the reward and relating it to the actions taken, our agent learns how to perform an action better, gather more cookie and get fewer fire. And of course, this reinforcement learning generality and flexibility comes with a price. And reinforcement learning is considered to be much more challenging area rather than supervised learning and unsupervised learning. So let's discuss about the complications we have in the reinforcement learning. So if your agents if your agent decide to do inefficient things, then the observation will tell you nothing about what it has done wrong and what should be done to improve the outcome. If the agent is stubborn and keeps making mistake, then observation will give the false impression that there is no way to get a large reward, which could be totally wrong. The second thing that complicates our agent's life is that it need to not only to exploit the knowledge it has learned, but actively explore the environment, because maybe exploring about other things will significantly improve the outcome. The problem is that too much exploration may also seriously decrease the reward. So we need to find a balance between these two activities. As we can see in the picture, a robot has some specific understanding where he can go to achieve his goal, like in the left direction, then upward, then one more step upward, then right, then again right, to get to the final goal. But what if it explores some other ways also, like going to the right, because there might be possibility it could reach faster. But this should be in balance, like the exploration and exploitation, which we will study ahead in detail, like where models should also try some other way to achieve the goal in the best way. So in that case, it should also not rely on too much exploration, because it would make it like a roam in the whole environment here and there, rather than completing the environment in some very minimum time. And the third complication factor lies in the fact that reward can be seriously delayed after actions. In chess, for example, one single strong move in the middle of the game can shift the game and shift the balance. So here are series N, and thank you.